Welcome back, my dear students.
In the last session, what we did, we know about the moment, okay, and we also learnt about the geometric representation of the moment. Now, on that concept, we learn a new concept or a new topic, that is Variance principle, or it is also called as what, principle of moment. Okay, it is on the same principle of the geometric representation of the moments what we did know. So that concept only, on that concept only, this principle arises. Now we will see what is this variance principle or principle of moments. So first we will see that statement. So if a number of coplanar forces are acting simultaneously on a particle, the algebraic sum of the moment of all the forces about a point is equal to the moment of their resultant force about the same point. So what they are telling, so a particle is there, okay, that statement I am telling you the meaning of the statement. So if a number of coplanar forces are acting on a particle simultaneously, okay, if more number of forces are there which are coplanar acting on a particle simultaneously, then the algebraic sum of all the moments about a point, let us consider this a point, okay. So this force, okay, I'll take this point as x, right? So this is force P, this is force Q. So the moment of Q force about x plus the moment of P force about x is equal to the resultant, is equal to the moment of the resultant force about the same point. Here they are telling that according to the statement, so the moment of resistance, okay, the moment of the resultant is equal to the moment of the force P with respect to x plus moment of Q force with respect to x. So this we need to prove in this statement. Okay, see again, I'll read the statement. If number of coplanar forces are acting simultaneously on a particle, then the algebraic sum of the algebraic sum of moment of all the forces about a point is equal to the moment of the resultant force about the same point. Correct? Now, moment of resultant force is equal to what? Algebraic sum of the moment of all the forces about the same point. Algebraic sum means it is a sum. ಎಷ್ಟು forces ಇರ್ತಾವೋ ಅದರದ್ದು sum. It's the addition of all the forces which are there, which are acting on that particle at that particular time. Now, see, this is the figure. So with this figure, what we do, we calculate or we prove that the moment of resultant force is equal to algebraic sum of the moment of all the forces about the same point. So see here, the force P is there and the force Q is there. So OABC is the parallelogram, okay. The force OA and the force OB will have a resultant R, okay. This is the resultant R, and OC is what? It is the diagonal of the this parallelogram OBCA, okay. Now X is the point. So I'll show you here in the next slide. Let P and Q be the two coplanar forces acting simultaneously at a point O. Let P and Q. P and Q are the two coplanar forces acting simultaneously at a point O. Let R be the resultant force and let X be the moment point. So X is the moment point for both P, Q and also for R. So X is the moment point or reference point for us. Okay. So in this figure, OA, this OA is equal to what? P, OB is equal to Q and OC is equal to R. Okay, of the parallelogram OACB. Okay, did you understand the nomenclature? So X is the point where we should calculate the moment. It is the moment point. Now we will prove. See, so moment of force P about X. So remember the geometric representation of the moment, that is moment of force P about X. So moment of this force about X. So P into perpendicular distance, but we don't have the perpendicular distance, but we have a triangle formed whenever we extend this line. So whenever we don't have the distance, we can use this concept. What is that? Moment of P about x. This moment of P about x is equal to what? 2 into area of triangle OXA. So this area, if we calculate, if we multiply 2 into area of this triangle, we are getting the moment of P about x. So this is the thing which we learnt in the last class. Okay, this is about P. Now what about Q? So I want the moment of force Q about x axis. So this is the force, right? So Q into x, and we don't have the direct distance, perpendicular distance will be like this, but we have here. So what we can do, 2 into area of triangle OXB. So wherever the force is there, so that related triangle we should take. For B, this is the triangle which we are considering. Okay, 2 into area of the triangle OXB. Correct? Next, moment of R about x axis. Moment of R about x axis. So this is the force R. Okay, so we are considering this triangle now. Area of the triangle 2 into area of the triangle OXC. This is the green one. OXC. This triangle area, A2 into area of this triangle. If we do, we will get the moment of R about x axis, about x, that is 2 into area of triangle OXC. Okay, what we need to prove? We need to prove that this moment of resistance R about x axis is equal to sum of this one plus this one. We need to prove. Okay, next, so the area of triangle OXC. So I'll take another color, or I'll erase all. So now see, area of triangle OXC. So this triangle, area of triangle OXC is equal to what? It consists of two triangles, that is area of triangle, that is 1 minute, I'll change the color. See, area of triangle OXC is equal to what? Area of this triangle, what is this? OXB plus area of this triangle, that is OBC. So this plus this will constitute what? Two triangles triangle OXC agutte. So what are the triangles? OXB and OBC. Okay. So in this parallelogram, that is parallelogram OBAC. So in this parallelogram, this OBAC, see here, okay, this is the parallelogram. So by the property of parallelogram, what we can tell? Angle, the triangle OAC, the triangle OA, the triangle this OAC, triangle OAC is equal to triangle OBC. Okay, triangle OAC is equal to triangle OBC. That's only we are writing here. Triangle OBC is equal to triangle OCA. Correct? Now, if triangle OAC is equal to OCA, by the property, see here, because they are in the same line, this triangle OAC is also equal to what? Triangle OXA. So I'll clear all the inks. See, this triangle OAC is equal to the triangle, this one OAX. So this triangle is equal to this triangle separately. Okay, whenever we consider triangle, we should take separately. Fine. So OAC, so that OAX, see this triangle OAX athava OXA is equal to triangle OCA, which is also equal to OBC. Okay, so when these are equal, then what can happen? So area of triangle OXC is equal to area of triangle OXB plus area of triangle OXA. So now what we'll do, we will multiply to both the sides. So 2 into area of triangle OXA is equal to 2 into area of triangle OXA plus 2 into area of triangle OXB. Okay. So from 1 and 2, what we can expect? So what is this? This is nothing but the moment of the resultant force. So R is what? Here see, the moment of resistance R about x axis is what? 2 into, that is 2 into area of this triangle, right? So what is this triangle? 2 into area of OXC. So what we got? 2 into area of triangle OXC is equal to, now, which is equal to, so the resultant is equal to individual forces, moment of P about x axis. The moment of P about x axis is what? 2 into area of triangle OAX, correct, plus 2 into area of triangle OXB, this triangle, correct. So hence from 1 and 2, the moment of resultant force R about x is equal to what? Moment of force about P about x plus moment of force Q about x is equal. Since we needed to prove this, and we proved this, hence the proof. So variance principle states that the moment of resultant force R about x is equal to the sum of the algebraic force of all the moments about the same point. Okay, so this was about the variance principle. Now we will see some of the examples on it. So problem number 1. So what is that? 3 like parallel forces. Okay, 3 like parallel forces, 10 Newton, 20 Newton and 30 Newtons are acting on a line ABC at A, B and C respectively. Find the magnitude, direction and distance of the resultant from the point A on a line ABC. See here the problem, see here, first to understand the problem. Okay, where it gone? Yes. See, sorry. 3 like parallel force. So 3 like parallel force, that is like parallel force, they are parallel to each other. 10 Newton, 20 Newton, 30 Newton are acting on a line ABC. Okay, at ABC respectively. Find the magnitude, direction and resultant. Find the magnitude, direction and distance of the resultant from point A on line ABC. So 3 forces are acting on this line ABC. Now we should find what? The resultant. Resultant means what? What the 3 forces, these 3 forces will make the line ABC, the same effect should make. So that force which makes the same effect as by 10, 20 and 30 mutually, that force, that the resultant force we need to find out. Okay, so what is the procedure? I'll let you know. See the figure C. So area A to B 3 meter is the gap, and between B and C it is 4 meter. Okay, now we have to find the, first we will find the resultant, the magnitude and direction of the resultant, and then we will find the distance from the point A. Now we should find the distance. So suppose if you think 10, 20, 30, here may be the resultant. Okay, suppose R will come here, the resultant force is here, then what we have to calculate? We have to calculate this distance from A, they are given point A. Okay, so see, this is the figure. So first we will resolve the forces vertically. So what are the vertical forces here? So another thing which I needed to tell you is, see, whenever you get a force which is inclined force like this, okay, if you get a force inclined like this or like this, okay, or slightly like this or slightly like this, okay, in the case if inclined force is given, then what you have to do? You have to resolve it to one horizontal ಆಗಿ resolve ಮಾಡ್ಕೋಬೇಕು, ಒಂದು vertical ಆಗಿ resolve ಮಾಡ್ಕೋಬೇಕು. Whenever inclined forces are given, you have to resolve in horizontal and in vertical. Suppose this is 10 Newton, okay, then angle will be there. It will, if it is given, angle also will be given. So I will take as 30 degree. Okay, then the horizontal force will be 10 cos 30 degree. Then we have to take consider this one, not this one, inclined force. Okay, here what we can take 10 sine 30 degree. The vertical component will be sine, the horizontal component will be cos. Another trick is that along the angle which we take, the with the angle will make no, that we will take as what, cos degree. So whatever let it be, horizontal component take as cos, vertical component you take as sine for basics. Okay, only it is when the inclined forces are given. If inclined forces are not given, take as it is. See here, pure vertical force is given, pure vertical force, pure vertical force, or pure horizontal force is also okay. You can calculate directly with the help of formula. See, now resolving, we will resolve the forces vertically. That is summation of V is equal to 0, taking what, upward as, taking upward as positive. What we do here, all the forces which are facing upwards, we will take it as we will add it and we will equate it to 0. Okay, see, sigma V is equal to 0 means what, so 10 Newton, how is the force, it is upward, positive 10 plus, okay, 20 Newton is there, 20 plus 30 Newton is there, 30. Then any other forces are there on this ABC, no force, is equal to what, we should equate to 0, but here we will directly find what, summation of vertical force. How much it is, 10 plus 20 plus 30 is equal to what, 60 Newton. Okay, so this I'll tell you later, 1 minute. So this thing I'll tell you later. Okay, then what I did, I just resolve the forces which are in vertical. I just summed up the vertical forces, 10 plus 20 plus 30 is equal to 60 Newton. See here. Okay, now resolving forces horizontally. So can you see any horizontal force? So horizontal force is like this. On A, are you seeing any force at, no force, right? So no horizontal forces are there. So sigma H is equal to 0 and sigma V is equal to 60 Newton. Now we can find the resultant. How? We have the formula. Yes, we have the formula, that is our resultant is equal to what, square root of sigma H square plus sigma V square. What is sigma H square? It is 0 plus sigma V square, what, 60 Newton. So 60 square. So root of 60 square is square root and square cancels, R is equal to 60 Newton, and it is also vertically up. Okay, if you find this 60 Newton negative, if you got 60 as negative, then your force is acting in downward. If you get vertical upward, if you get positive value, it is vertically upward. Okay, so what we did, we had these forces, we just took sigma V, we calculated sigma V, we calculated sigma H, then we calculated what, resultant force. Resultant force is what, square root of sigma H square plus sigma V square. So H square is 0 square plus 60 square, so R is equal to, so resultant force is what, 60 Newton acting vertically up. Now we found now we found the what, resultant force, that is 60 Newton. Okay, 10 20 30 Newton ಎಷ್ಟು effect force create ಮಾಡುತ್ತೋ ಅದಷ್ಟೇ force 60 Newton force create ಮಾಡುತ್ತೆ, like that its meaning. So 60 Newton acting vertically up. So where we should place this 60 Newton from A, they are asking in the question. So in the question, see, find magnitude. Yes, we find out the magnitude. So we didn't find the direction theta, that is tan inverse of sigma V by sigma H, we need to find. Then also we have to find the distance from the resultant from point A. See, now we found out what, R is equal to 60 Newton. Next we will find out the that R is 60 Newton, act at a distance of X from as shown in figure. See here, we will consider R here. Okay, it is 60 Newton. So from A to B is 3 meter, B to C is what, 4 meter, right? So A to C is 7 meter. I'll consider this R in that ABC line at a distance of X, and we need to find the distance X, right? So taking moment about A. Okay, we should take moment about A and apply variance principle. How to take moment about A? See here. So what is the variance principle? Moment about R, okay, the moment of the resultant is equal to what? Algebraic sum of the moment of all the forces. That is, moment of resultant is equal to moment of 10 Newton plus moment of 20 Newton plus 30 Newton. So 10 into what? About A. So about A, it is 0, right? Okay. What is the distance of 10 Newton from A? It is 0. So it is 0. So 20 into 3 meter. Next 30 into 7 meter. 30 into 7. A is 7 meter distance. Okay. So 20 into 3, 30 into 7, which is equal to what? The resultant is 60 into x. So 60 into x is equal to 20 into 3. 60 plus 30, 3 sevens are 210, like that. So minus 60x. Why minus? Because resultant is making what? Anti-clockwise direction. It is also very important about A. So about A, R is upward. See, I will show you. So about A, R is making what? Anti-clockwise direction about A. If R is like this, we could take that directly 60x. But R is what? Negative. R is anti-clockwise. So we have to take minus 60x, which is equal to this 20. With A, it is minus 20 into 3. Then plus minus 20 into 3 plus then minus 30 into 7. So on simplification, what happens? Minus 60 plus into minus minus 37 to 10 will happen. So like this we need to solve. Okay. So once we solve, so what we get? We are getting minus 60x is equal to what? Minus 270. Then x is equal to what? 4.5 meter from A. So x value of x is what? 4.5 meter from A. The value of R. So R is a correct value. So x is what? 4.5 meter from A. So by using the moment concept in the variance theorem, variance principle, we can calculate the distance of resultant from the point A. Okay. Did you got it? So we'll check out the next question. So four parallel forces are acting as shown in figure. Find the magnitude and distance of resultant from A. So four parallel forces. See, all the forces are parallel forces and it is on the same line A, B, C, D. So what is the distance? 1 meter, 0.5, 0.5 meter. What we need to find? Find the magnitude and distance of a resultant from A. Here also same concept. We have to find the resultant, then we have to apply the variance theorem, that is moment of resultant is equal to about A, right? About A, from A, then we have to say moment of resultant is equal to B into this distance, C into this distance, D into distance about A. So C 1 plus 0.5 plus 0.5 for 200 kilonewton. Okay, I'll show you. I can write here only, but okay, no problem. So yes, we will go to the solution. So this is the figure. So resolving the forces vertically. First we will what? First step is to resolve the forces vertically. That is sigma V is equal to how much? So 100 kilonewton. So 100 plus what? 150. But it is acting downwards. So take negative 150. Okay. Then what? Minus 25. Okay. Then what? Plus 200. Then add them. You will get sigma V is equal to 125 Newton, which is a positive value, means the sigma V is positive. Correct. Next, resolving all the forces in sigma H equal to 0. Okay, that is sigma H equal to what? It is equal to 0 because what? No horizontal forces can be seen on the ABCD point. Okay. Next, resultant R is equal to what? resultant how we finding? So r is equal to what? Sigma h square plus sigma v square. Same formula we have to follow. Sigma h square is 0 plus it is 125 whole square. This square and this square root cancels. So what we will get? R is equal to what? 125 Newton only. Fine. So we got the resultant value, that is sigma v is 125 Newton. Now we have to find where we should place the r value. Then also we will consider r here only and we will take a distance of x from point A. So we will see here. So A is here. So we placed R here. R is equal to what? 125 Newton. So resultant is placed here. So A, this is B, okay, this is C and this is D. So B is at 1 meter distance from A, C is 1.5 meter distance from A and D is 2 meter from A. Now R is what? At a distance of X from point A. So applying what? The resultant R 125 Newton acts at a distance of X from A as shown in figure. Now what we are doing? We will apply what? Varinger's theorem, that is minus 125 into X. Why minus? Because it is making what? Anti-clockwise direction. It is making what? Anti-clockwise direction. R is making anti-clockwise direction about A. So it is minus 125 into X, which is equal to, okay, so 100 Newton about A it will not create because the resultant X is 0, means the distance is 0. About 1 we will come here 150. So but 150 it is making what? Clockwise movement. This 150 will make clockwise movement about A. This will make clockwise movement about A. So 150 I'll take as positive. So 150 into what? What is the distance between them? It is 1 meter. Okay. So next C also it will make what? Clockwise direction. See the arrow mark you see. So arrow mark is making what? Clockwise direction. So what? Plus 25 into what is that? 1.5 meter. Okay. Next what is D? So D is arrow mark you see. So it will make what? Anti-clockwise. So minus D into 2. Minus D means it is 200. 200 into 2. Correct? So I'll write C. So taking moment about A and applying Varinger's theorem. So minus 125x into 150 into 1. So y positive, I already told you, clockwise moment, plus 25 clockwise moment, minus 200 into 2, that is anti-clockwise direction. So when we solve this, minus 125x is equal to minus 212 minus 5. Then after solving, we will get the x value as 1.7 meter from A. So the resultant is 1.7 meter apart from A. So R is 1.7 meter from A. Okay. For example, if you place wherever you place the x value, what it comes, it will come. Okay. There is no confusion that you have to place R here only, R here only, like that. Okay. There is nothing problem. Fine. Wherever you place, just follow the method, the concept, you will get the value of x is 1.7 meter. So with these two examples, I'll conclude today's session. So another two examples I'll solve in the next session.